Algebra 2, number 6.8b, solve rational word problems with formulas, or formulae. That's the plural. Either way is okay. If you haven't seen the previous videos for Chapter 6, I don't want you to get confused. There's links in this video's description so you can click on them and watch them before you watch this one. So take a look at this. We might need to look up a formula or a definition to understand a problem completely. We also may need to solve a formula for a certain variable. The most efficient way to do this is to set the formula for the desired variable first. So I went online and I was able to print this out. I even posted it to my Twitter account, the link to print this out. It's got all the formulas, the basic ones that you would use for Algebra 2, and sometimes we need to switch them around. So if it says that this is set to equal y, we could set it to equal b, couldn't we? By moving the formula around. We've learned that in the last couple of videos. So in this one, for distance equals rate times time, how long did it take to drive 60 miles going 30 miles an hour? Well, we need to solve for time. It's saying how long did it take? And it's set to equal distance. So we could solve it this way, but it's a lot easier to set it to the t. We need to do 60 miles equals 30 miles per hour times the time if we do it this way. And we could divide both sides by the 30 and then get our answer. But if we set the formula to equal t first, then we can just do the 60 divided by 30 and get the 2. So you can still solve it the other way, but it might be a lot tougher, especially when the formula is very, very involved, okay? Because if you look, some of these formulas have a lot of variables in them, so it might just be easier to set it to equal the one you're looking for, okay? All right, we're going to talk about electricity in this video. Two electrical resistors are connected in parallel. Okay, well, first of all, these are electrical resistors. And it says it's a passive two-terminal electrical component that implements electrical resistance as a circuit element. So this is used in electricity, and the electricity goes through there, and the resistors can adjust the electricity. See? It adjusts the signal level, it can divide voltages, it can even end transmission lines, okay, terminate them. All right, so that's what resistors are, and they're real pretty and colorful right here, and they've got ceramic on them, okay? So the resistance of one of them is 6 ohms, and the resistance of the combination of 2, because we have 2 of them, here's a picture of 3, but we only have 2. So one is 6 ohms, and the combination of the 2 of them is 3.75 ohms. So we want to know what the resistance of the other resistor is. So this is a diagram of resistors in parallel that I got off the internet. So if we know this one is 6 ohms, and we know together they're 3.75, what is the second one? So it's set as R sub 1 and R sub 2. The rule for finding the resistance of a combination is given by this formula. 1 over capital R equals 1 over R sub 1 plus 1 over R sub 2. This R sub 1 and R sub 2 are the resistance of the individual resistors, these guys, and this big red R is the combination. So we know that is 3.75, and we know R sub 1 is 6. We just need to find that one, okay? So we set the formula to solve for R sub 2. I'm going to change this so that it equals R sub 2, okay? So we multiply each term by the LCD, that least common denominator. And our common denominator is R sub 1 and R sub 2, isn't it? Now, I know some people are thinking, well, why can't I just put this over here after the equal sign and then solve it? Because you can't add fractions that have uncommon denominators. We've got to get them to have a common denominator before we can add them, right? So we need to do the LCD. And we multiply every single term by that LCD, that capital R, R sub 1, R sub 2. And you can see that these two red R's are going to cancel each other out. So on this side of the equal sign, we're just going to have an R sub 1, R sub 2. this r sub 1 is going to cancel out that r sub 1. So the only thing left is going to be the capital R and the r sub 2 here. This r sub 2 is going to cancel out with that r sub 2 as a 1. So the only thing left is going to be an r sub 1 here. Okay? So now we can start isolating for r sub 2, because that's what we want to solve for. So here's our equation right here. Okay? I just took it off the 1s. And we can subtract this r sub 2 from each side of the equation. Okay? Or you could say we're adding a negative to make a zero pair, to make additive inverses. So now it's eliminated from here, and we put it on this side. Okay, so we got r sub 1, r sub 2, minus r times r sub 2. See that? And remember, these are multiplied together also. And it's going to equal this one. See? Now, if you look at this, this can be factored. We have an r sub 2 here and an r sub 2 there. So we could put it on the outside of the parentheses times r sub 1 times that negative r, and we'll be back to here. So we can factor it as this. Now, if you look, we've got him kind of by himself, don't we? And if we divide both sides of the equation by this r sub 1 minus r, he'll be by himself on this side, won't he? And on the right side, we'll have the capital R times r sub 1 over r sub 1 minus the capital R. See? So now we're ready to plug in our numbers. We know our numbers are 3.75 and 6 ohms, so we're going to plug those in to this equation, and we get 3.75 times 6 over 6 minus 3.75, and substituting in those actual values. And 3.75 times 6 is 22.50. 6 minus 3.75 is 2.25. When we do the division, we get 10 ohms. So we know the r sub 2 is 10 ohms. See? They all had different denominators. So we couldn't just subtract them, could we? All right, let's try a different one. So this is almost the same thing, except now we're going to be looking for the capital R. All right? So two resistors are connected in parallel. Again, the resistances are 8 ohms and 15 ohms. What's the resistance of the combination? So we know that that big red R is our combination. We know R sub 1 is 8 ohms. R sub 2 is 15 ohms. We need to find a common denominator. We can't just add or subtract them if they don't have a common denominator. So we've got as our LCD the same thing, R sub 1, R sub 2. And we multiply each term again by that LCD. This r sub 1 and that r sub 1 cancel each other out, so all we're left with is the capital R and r sub 2 here. This r sub 2 cancels out with that r sub 2, so all we're left with is the capital R and times the r sub 1 for here. And that capital R cancels out that capital R as a 1, so all we're left with is r sub 1, r sub 2 on this side, okay? Now we can factor it. See how we've got the two big r's? We can factor it as r times r sub 1 plus r sub 2, see? And if we divide both sides of the equation by this, we can isolate that r. And we're left with this. So now if we plug in our actual numbers, 8 and 15, we know that the r sub 1 was 8 and r sub 2 is 15. 8 times 15 is 120, and 8 plus 15, see, is 23. And we can actually leave it like this. We don't need to go any farther. That's acceptable as an answer. If you did continue and do 120 divided by 23, you get this really long decimal that doesn't make any sense to have to write or anything. So just leave it like a fraction, okay? So just remember the key to solving is that LCD, that least common denominator, all right? And I know that it's very, very easy to look at this and say, well, I'm just going to add this and this. I'm going to add 1 over 8 plus 1 over 15 to get that answer. But you can't, because they're not, you can't do 1/8 plus 1/15. You need to find a common denominator, don't you? All right? So our next video, 6.9a, is going to be about direct variation and constant of variation. I'm going to add this one to the Algebra 2 playlist. There's a link to 3.7 from Algebra 1 that did this with formulas, and any of the helpful Chapter 6 videos that we've just covered, those links will be in here too, okay? So now you get to learn a little bit about electricity. And when I was taking algebra, I printed out stuff like this, or I wrote them into the cardboard cover of my spiral. And then that way, anytime I needed to look up a formula, it was right there in my spiral. And even the 5-star spirals are good because you could write it on the pocket. Okay, so I'll see you next video. I hope you're doing well. I'm proud of you. Keep going. We're making it. Bye.